Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the remove all adjacent duplicates in a string problem. You are given a string S consisting of lowercase English characters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after all such duplicate removals have been made. It can be proven that the answer is unique. So here, if we're looking at A, B, B, A, C, A, we see the two B's can be removed, but as soon as you remove those, the two A's are next to one another, so they can be removed as well, and the C and A get left behind. Similarly down here, we remove the two X's, then we see the two Z's are next to one another, leaving the A and the Y. We did a problem very similar to this the other day actually. If I can work out how, there will be a link on screen now to go watch that video. We did that one in Python, and I talked a lot about how stacks work. So today, just to make things a little more interesting, we'll do the same algorithm, because I believe it is the same algorithm, but we'll do it in C, just so we can play around a little bit more with what exactly is going on. So, to recap the theory, the idea is that I'm going to maintain a stack. Now, a stack is a data structure where you can only access one end. So the idea, we talked about this, was if we have a plate of pancakes, I can put pancakes on the top, and I can go as many as I like from the top, but I can't go into the middle and start removing pancakes. That gets very messy and you end up getting syrup everywhere, and no one wants to do that. So, how do we use this to maintain or to remove all the duplicates? Well, the idea is we're going to use a stack. I'm going to have an empty stack to begin with. I'll put a bar here to show that it's empty. And then what I'll do is I'll push the A on. That's safe because there's nothing on the stack. Then I'm going to push the B on, and that's fine because it doesn't conflict with the A, so the B can go on. When I go to put the next B on, that's when I notice a problem. The two B's are adjacent and equal, so they're both going to come off. I then go to put the A on, but again, I notice these are equal and now adjacent, so they both come off. The C can go on because there's no problem. There's nothing stopping it from going on. And the A can go on as well. It's not equal to C. So there's no problem stopping it going on the stack. And then we end up with CA, just as the problem specifies. We'll quickly run through that here with this one here. So we see the A, that can go on, the Z can go on, that's safe, the X can go on, that's perfectly safe. But as soon as I try and put on that next X, I see I have to take both of my pancakes off the stack. I go to put the Z on, sure enough, we've got a problem, they come off. Y goes on, no problem, AY. That's our outcome. So, let's do this in C. Now this is where things get a little more difficult. So what I'm going to do is I'm going to manipulate the string in place. So I'm going to return the same string that I was given. Is this a good idea? Debatable. But C lets us do it. So let's do it that way. Just because it's quite different. In Python, strings are immutable, so there was no chance for us to do this. We couldn't manipulate the string in place. C lets us manipulate it in place, so this is quite a different implementation of the same algorithm. So int top is going to start at -1 because there is no top of anything that I'm looking at. For I, int I equals 0, I is si is not null. I++, this is how you walk through a string in C. So if you've seen this kind of loop before, normally you're doing some length comparison here. In C, strings don't have a length associated with them. They have an end character, which is null. So we just need to keep walking until we hit this null character. So that's what I'm checking here. Starting at 0 and stepping 1 each time, keep going until you're out of characters. Now, what I want to do is, if top is less than 0, continue. I don't need to do anything. But there's another case where I don't need to worry about, in fact, I need to go further. I need to say increment the top, because I'm effectively pushing something onto my stack without problem. But there's another case where that can be true, and that's where s top does not equal s I. That's also a perfectly safe case to push something onto the stack. So to do the actual pushing, we increment top, and we're going to say s of top is s of I. If we're not allowed to do this, basically what we want to do is we want to decrement the top. We've seen something bad that we need to pop off, and because we need to make sure that we've got valid strings everywhere, we're going to set that to be null, to say, well, if we're done, we might be done, we don't know yet, then we want to set the end of the string to be null. So let's slowly work through this. In fact, let's do a full trace down here. Top starts at -1. I starts at 0. Si, and S is going to be A, B, B, A, C, A, with the null character on the end. So what's going to happen is top is less than 0. So we're in this case here, we're going to increment top, we're going to set it to 0, and we're going to set S0 to be S0. That's fine. We're going to go through again. I is now 1. Top is not less than 0, but let's check 0 and 1, S0 and S1. They're different, so we're in this case again. So top gets incremented to 1. Top and I are the same, 1 and 1. S1 gets set to S1. I don't need all this space. We're going to go around again. I is now 2. Top is not less than 0, but S1 and S2, S top and Si, they're equal. So we're in this case. We want to bring top down and set it to be... Oh, I shouldn't have done that, should I? I just want to not push. So I don't want to do this minus minus. I want to leave that as a 1, but I want to set this to be a 0. Saying this is the end of my string. We go around again. I goes to 3. 0, 1, 2, 3. So now we're looking at this A here. Top is 1. Oh, no, top. So I do need to do the top minus minus actually. I just need to do it in a different order. So the top goes back down to 0. Actually, you know what? Let's unwind back to where we were. We had top 2. This was B. I was 3. So we're now looking at no, hang on. What do we have? Let's start again. I've got myself confused. Top is -1. I is 0. So we're looking at 0, -1, this gets set to 0, and this sets A to A. The I goes to 1, 1 and 0, they are different, so we're going to increment top and set B to B. I goes to 2, B and B match, 1 and 2 match, these two here. So what we do is we set the top, which is position 1, that becomes a 0, and we decrement this. I goes to 3, so now we're looking at the A and the A, 3 and 0. These are the same, so we're in this case here, this gets set to 0, and this top gets decremented. We go to 4, 0, 1, 2, 3, 4. This C here, C, well, top is -1, so immediately it goes to 0, and we're going to write 0. So we're going to write index 0 gets assigned the C. I goes to 5, 0, 1, 2, 3, 4, 5. This one here, A and C do not match, so we increment top and write the A in there. That's what we need to do. We'll fix that in a second. And then we're done. So the mistake I just found was that all of this is still in the string. Final check, 6, that's the null, so we're done. But this here is too long. It retains all of this garbage. So what we need to do here is say SI is definitely the null character. So I had to move this I initializer outside of my for loop, just so I can still access I when we get to the end. And this tells me, oh, no, I don't need to do that. What am I doing? I don't want to set I to be where we are. I want to set top to be where we are. And it's top plus 1. So 1 above where we finally ended. I think that'll do it. So quickly running through this version here, we're going to say A goes on, Z goes on, X goes on. X doesn't go on, so top zooms down to here. Z doesn't go on, so top goes back to the A, and then we put the Y on where the Z was. Then we're going to write the X to be null, so you're going to get with A, Z, null, and some other junk, which is never going to be read. So that's an interesting quirk of C strings. You can have lots of memory allocated, but if there's a null somewhere in the middle of it, you're never going to find it, because it's all going to be stopped where that null is. So let's run the code. Good. That seems to work. Let's run it again. Fantastic. And we'll submit it. Perfect. Again, these numbers are fairly meaningless, although they certainly make me feel good. This is a fast solution. Yay. But again, it's the stack manipulation. The only difference to how we're doing it last time is last time we were explicitly maintaining the stack. We were pushing and popping and doing all that kind of thing. But here what we're doing is we're maintaining a stack pointer. We're maintaining an index, basically, that says where the top currently is. A different way of thinking, same underlying algorithm. That's something you'll find a lot when you're programming. The different languages give you different features, but the high-level concepts like stacks and queues and searching and sorting, these are consistent between languages. They just might look a little different. Anyway, do let me know how you got on. Do go check out the other video if you want to see this done in Python in a slightly simpler language. Do remember to like, comment, subscribe, all of that good stuff. It really does help out the channel, and you've been so amazing recently. We're almost at 50 subscribers, which is absolutely crazy. Well, that's it from me. I will see you next time. Bye.